In this video, we're going to go over the discriminant. The discriminant is another tool like factoring or the quadratic formula that'll help us determine how many x-intercepts a quadratic equation has. Now, the quadratic formula and factoring actually find what the x-intercepts actually are. The discriminant is going to tell you how many x-intercepts it has. You can have a quadratic that looks like this, and it's going to intersect the x-axis in two spots. Or you can have a quadratic that's going to look like this. It's going to intersect the x-axis in one spot. Or you could have a quadratic that would never intersect the x-axis. The discriminant, which looks like part of the quadratic formula, is used to determine how many x-intercepts it has. Mathematically, it's going to give you an idea of what the picture is going to look like. So what you do is you make sure the quadratic is in standard form. Once it's in standard form, you're going to have an A, a B, and a C. You're going to plug the A, B, and C into this little formula right here. Determine what it is. Once you do the math, if the number you get right here is greater than 0, then it's going to look something like this. It's going to have two x-intercepts. If you plug in the numbers for A, B, and C, you do the math and you get it equal to 0, that means it has one x-intercept. It's going to look something like this. If you plug in the numbers for A, B, and C, you do your math, and you find out that the discriminant is less than 0, that means it's going to have no x-intercepts. So here's the little formula that is the discriminant. You use it to determine how many x-intercepts you're going to have. A lot of times people will use this formula before you factor or before you use the quadratic formula to see if you even need to do that, because if it doesn't have x-intercepts, you can't use the quadratic formula to find the x-intercept. So here's our first example. We're going to find the discriminant of this quadratic, and we're going to determine how many x-intercepts this has. Remember, the discriminant is equal to b squared minus 4ac. You make sure the quadratic is in standard form. This will be your a, this will be your b, and this will be your c. You plug those numbers into this formula. Your b is going to be 5. 5 squared is 25 minus 4, and I'm going to multiply a and c together. A is this number in front of x squared, that's 1, times 4 is 4. Negative 4 times 4, negative 16. And 25 minus 16 is 9. My discriminant is equal to 9. If I remember, if my discriminant is greater than 0, there are two x-intercepts. If my discriminant is equal to 0, there's one x-intercept. And if my discriminant is less than 0, there are no x-intercepts. So look at this, and I see this is a 9. 9 is greater than 0. I have two x-intercepts. Then I would use the quadratic formula or factoring to figure out what those x-intercepts are. Second example, I'm going to use the discriminant. And remember, the discriminant is this little formula right here, to determine how many x-intercepts this quadratic has. Remember, it needs to be in standard form, so I know what my A, my B, and my C are. I plug those numbers in there. I take negative 12 and plug it in here and square it. Negative 12 squared, negative 12 times negative 12 is 144. Minus 4, I'm going to multiply A and C together. 4 times 9 is 36. I need to multiply these two together. Negative 4 times 36 is negative 144. 144 minus 144 is 0. So remember, if the discriminant is greater than 0, that's 2 x-intercepts. If the discriminant is equal to 0, 1 x-intercept. And if the discriminant is less than 0, no x-intercepts. So looking at this, since my discriminant is equal to 0, I'm going to have 1 x-intercept. And then I would use something like the quadratic formula or factoring to figure out what that x-intercept is. For our next example, we need to find the discriminant again, and then use that discriminant to see how many x-intercepts this quadratic has. So remember, the discriminant is b squared minus 4ac. That means this quadratic needs to be in standard form, so I'll know what my a, b, and c are. I begin to plug those numbers into my formula. B is 5. 5 squared is 25. Minus 4 times A times C. I'm going to multiply A and C together. Negative 3 times negative 8 is positive 24. I need to multiply negative 4 times 24. That gives me negative 96. And 25 minus 96 is negative 71. My discriminant is negative 71. Remember, if the discriminant is greater than 0, I have 2 x-intercepts. If the discriminant is equal to 0, I have 1 x-intercept. If the discriminant is less than 0, I have no x-intercepts. So how many intercepts does this one have? It has no x-intercepts.